Hello everyone, welcome to our 8.3 video. And so the only vocab we need for 8.3 that's new is standard form. So this is going to look like f of x equals a times x squared plus b times x plus c. And in standard form, we still have the dilation just like we did in the vertex form. And then at the end, the other thing we can see is the y-intercept. So in vertex form, you can see the dilation, the vertex, and then here you can see the dilation and the y-intercept. So we're going to go ahead and jump to our guided notes. Okay, so what I would like for you all to do is treat this like we were in class and do this top explore a reason as a warm-up. So go ahead and pause the video and then just answer these. Remember that these are just like what you think, so there is no right or wrong here. So go ahead and pause the video and try those. Okay, so again, you could have many other different answers here because there is really no like right or wrong, since it's just what do you think they have in common, what do you think they differ in. And so they all have the same kind of shape, but they do kind of go in different spots. And then they all share this x-intercept right here, but then they all have an additional one. They all have the same y-intercept though, right here. So remember, y-intercept is on the y-axis, x-intercepts are on the x-axis. And then here they are asking you to take your b value, so this one here, and then put it on top of your a value, so this one there. And the red one got 1, blue got 2, green got 3. So what do you notice? That they're going up by 1 as they move downward, or just they're going up 1. So let's go ahead and take a look at example 1. So it's asking, what information does C provide from the graph? Well, we said that in our vocab that C was the y-intercept. But let's go ahead and check the graph and make sure that that's really what it tells us. So we're going to be looking at the point that it touches the x-axis, so that one right there. I don't know why it did that. So right here, why is it moving down? Sorry, some more technical issues here. Let's go ahead and just try a different pen. Okay, so right there. Right. Okay. I'm going to pause the video. Okay, so for some reason it's not letting me draw on the graph, so it is the y-intercept right here. So if we go from 0, it's up 1, 2, 3. So it's y-intercept there. This one would be down 2. So 1, 2. And this one would be up 6. So here's 10. Here's 5. Yep. So it tells us the y-intercept. Okay, so going on down to example 2, we're going to graph this quadratic function. So in vertex form, we could just start with the vertex. Here we don't know the vertex, so we have different steps that we have to follow. So we are going to go ahead and write each step to be helpful for us. So the very first step, excuse me, is you find the axis of symmetry. And you do that by using this little formula where you do x equals negative b over 2a. So in quadratics, one thing to kind of note is that in standard form, it's ax squared plus bx plus c. And so it's this number in front that we're looking at to get here. So your b value would be 4 in this case. Your a value would be 2. And then your c value would be 3. So now going back to this, plug in your value. So there's a negative there, so you keep that negative. And then our b value, which was 4 over 2 times our a value, which is 2, which is negative 4 over 4, which is then negative 1. So our axis of symmetry is x equals negative 1, which means on this graph, our parabola, the middle, is going to be on this line right here, and it's going to reflect on both sides. So again, axis of symmetry is x equals negative 1. Okay, then the next step is to find the vertex. And the vertex you're going to find by, we have the x value of it. We know it's going to be somewhere on this line. So now plug in that to your formula. So 2 times negative 1 squared plus 4 times negative 1 plus 3. So again, this is the x value, and now we need the y value. So we're going to find that. So do that in your calculator, and you get that it's equal to 1. So the vertex is negative 1, 1. So negative 1, 1. And so right here is our vertex. Okay, then plot the y-intercept. So remember, we look right there, and so our y-intercept is 0, 3. 0, 3. Okay, then we need another point. So plot another point. And its reflection. Sorry. For the y-intercept, I forgot we also need its reflection. So what it means by that is this point is on this side, so then there's also one right on the other side right here. So now let's go ahead and find one more point. So let's plug in 1 to get where this one would be here. So plugging in 1, we would do 2 times 1 squared plus 4 times 1 plus 3. And then find that answer. So then you would get 9. So this point would be 1, 9. So plot that one. 1, 9. And then the same thing over here. So 2 away, so 1, 2 over here. And then after that, just go ahead and draw your parabola. Okay, so that is everything we needed to graph it. So with using those steps, go ahead and graph this one here. So pause the video and give that a try. Okay, so first step, find axis of symmetry, negative b, so negative 2 over 2 times 1 equals negative 1. Do the next step, find the vertex, so plug in this for your x in the equation, solve it. One thing to note is make sure that you put parentheses around negative 1 when you square it on your calculator, otherwise it'll give you 1 squared times a negative. Do the next step, plotting the y-intercept 0, 4, and its reflection on the other side. Over one more. There you go. And find another point in its reflection. So I plugged in 1, found that point in its reflection, and then I drew the parabola. Okay, so then that is that one. If you have any questions, please email Miss Holstad and I. Let's go ahead and look at example 3. So it's asking us that the trajectory of the water for fountain A is here, and it's in standard form, and then fountain B is in a table, and it wants to compare the vertex of each function and find which one has a greater height. So to find that, we need to find the vertex of each one. So for fountain A, we're going to find the vertex by doing our x equals negative b over 2a, so 2, and then 2 times our negative 1 for a, so that would be a positive 1. Plug that in to our function, so negative 1 squared plus 2 times 1 plus 8. So this time the negative is on the outside and it's just 1 squared. So our vertex is 1, 9 here. And then for fountain B, we need to figure out where the vertex is on the table. So if we look, it goes 5, 8, 10, 8, 5. So we can see that it starts repeating itself right here. So this is the vertex, negative 4, 10. So which one reaches higher? This one reaches 9. This one reaches 10, so fountain B reaches higher. Okay, and we have one more example. So now we're looking at this girl tossing a ball to her dog, and it has a function here, and it says, what do the vertex form tell you? Well, it's vertex form, so it tells us the vertex. So the vertex is 2, 8, remember, because it's this one here, and it's opposite of what you see. And what does this tell us? It tells us at 2 feet, the ball is 8 feet high. Okay, and then it wants you to write this in standard form. So if it was in standard form, what would it tell us? It would tell us the y-intercept. So let's go ahead and get it in standard form and find the y-intercept. So what we're going to do is we're going to go ahead and just simplify this. So we're going to square this. So we're going to do x minus 2 times x minus 2 and then add 8. So here, this would be our FOIL, x squared minus 2x minus 2x plus 4. And we would do that, and then we would times it by 1/2 and add 8. Go ahead and give that a try. Okay, so doing that, we would combine our like terms right here to get negative 4x. Then distribute that 1/2. So this would become negative 0.5x squared. 4 times 1/2 is 2, 4 times that 1/2, and then add. So then it's standard form. So what is our y-intercept? 0, 6. Y-intercept is 0, 6, so the ball starts at 6 feet high, which we can see on that graph there. Okay, so I hope you understood this. If you have any questions, please email Ms. Holstad and I, and we will do our best to help you. Thanks. Bye.